Imagine pointing a laser pointer at the moon and actually seeing that light bounce back to you. That was the audacious dream of the scientists behind the laser-ranging retroreflector. For centuries, we could only guess exactly how far away our celestial neighbor was. But in the late 1960s, NASA decided we needed a definitive answer. They didn't just want to visit the moon. They wanted to turn it into a scientific partner. By leaving a simple, suitcase-sized array of high-tech mirrors on the dusty lunar surface, they created a way for us to touch the moon from Earth every single day. It was a bridge built of light, designed to help us understand the very heartbeat of our solar system, from the way the moon wobbles in its orbit to the secret liquid fire deep within its core. On July 20th, 1969, the world watched in silence as Neil Armstrong and Buzz Aldrin stepped onto the Sea of Tranquility. Amidst the chaos of the first moonwalk, one of their most critical tasks was the deployment of the Apollo 11 retroreflector array. It was a humble-looking device, a small panel, containing 100 fused silica half-cubes, but its impact was monumental. Buzz Aldrin carefully carried the experiment away from the lunar module Eagle, searching for a level spot on the ancient gray dust to ensure the mirrors pointed directly back at Earth. Just hours after they set it down, the Lick Observatory in California successfully bounced a laser beam off the array. It was a historic handshake between two worlds, proving that while the men would leave, our connection to the moon was now permanent. The mission didn't stop with Apollo 11. To truly understand the moon's movement, scientists needed more points of reference. On February 5, 1971, Alan Shepard and Edgar Mitchell added a second array during the Apollo 14 mission at Fra Mauro. A few months later, on July 31, 1971, the Apollo 15 crew, David Scott and James Irwin, deployed the largest one yet at Hadley-Appomattox. This massive panel featured 300 mirrors, making it 3 times more powerful than the others. Interestingly, the Americans weren't alone. The Soviet Union also sent their own robotic walkers. In 1970 and 1973, the unmanned Lunokhod 1 and Lunokhod 2 rovers landed, carrying French-made reflectors. While Lunokhod 1 was lost for nearly 40 years, it was rediscovered in 2010 by NASA's Lunar Reconnaissance Orbiter, and it still reflects light perfectly today. Together, these 5 sites form a global lunar network that researchers use to triangulate the moon's exact position in space. How do these mirrors work for over 50 years without a single person there to clean or power them? The secret lies in a clever design called a corner cube reflector. Imagine the corner of a room where 2 walls meet the floor at perfect 90-degree angles. If you throw a ball into that corner, it will bounce off all 3 surfaces and come right back to your hand. These arrays use the same principle. Each of the 100 quartz cubes in the Apollo 11 array was carved into this precise shape. Because of this geometry, any laser beam sent from Earth, even at an angle, is reflected exactly 180 degrees back to its source. They require 0 electricity and no moving parts. While they have become a bit dusty over the decades due to micrometeorite impacts, their simple, rugged design makes them the only Apollo experiments that are still fully operational. Today, the mirrors left behind by heroes like Neil Armstrong and David Scott have taught us more about our solar system than almost any other experiment in history. By timing how long it takes a laser pulse to travel roughly 2.5 seconds. For the round trip, scientists have discovered that the moon is spiraling away from Earth at a rate of about 3.8 centimeters, 1.5 inches per year. This constant stream of data has also confirmed that the moon has a fluid core and has allowed us to test the limits of gravity itself. Even now, over 5 decades after the last human footprint was made in the lunar dust, these silent sentinels continue to work, proving that the greatest bridge between Earth and the stars isn't made of steel, but of light and human curiosity. Now that you know the story of the mirrors on the moon, it's time to look up. Next time you see a full moon, remember that a piece of human technology is looking right back at you, waiting for the next laser pulse. Share this story with a friend or leave a comment below. If you could leave one permanent object on the moon to be found 50 years from now, what would it be?